like to talk about the AP chemistry exam. Now, one of the things about the AP chemistry exam that's very important is that those learning objectives we're talking about all link up to the questions. So every question on the AP exam, whether it's on the multiple choice or on the free response, is linked to one of these learning objectives. So if there is a topic you want to know, is that really on the test or not? Just look at the learning objectives. If there's not a learning objective, then you're not going to see a question on the exam about that. Now, the overall idea is that, it's half and half multiple choice and free response questions. Okay, the kids get 90 minutes to do the 60 multiple choice questions on a normal test, not this year. And then they have 105 minutes, which is 90 minutes plus 15 minutes for reading to do the free response questions. Now, this is 60 questions, but those 60 questions, actually, there are 50 that are going to be part of their score. The other 10 are placed in there. They're questions from old years, and those are ones that will kind of norm the population, let the statisticians know whether this group of students taking the exam is better qualified or less qualified, better prepared, less prepared than other years, okay? On the free response questions, there's going to be 3 long 10-point questions, and there'll be 4 short, 4-point questions. There are a lot of words that are going to be showing up in the exam, and it's kind of nice to look at this. Okay, what 2 other I'd like to point out, explain. When they ask you to explain something, then they really are talking about going back to, first principles, Coulomb's law, do a little math, talk about the physics that explains something. When you talk about justify your answer, that's just really kind of talking about what is it that you are thinking. What, you're not just pulling this answer out of the air. What is your logic behind this answer? Now, we want to look at a few of these questions. Now, one of these, would be, notice there's only 4 answers on each, is A, B, C, D. So for this question here, which of the following species has the electron configuration shown above? Now, one thing I try to teach the students is don't look right at these answers first. Go back to here. And if you were looking at this, you'd say it's 1s2, 2s2, 2p6, 3s2, 3p6. That's 2, 4, that's 10, 11, 12, 18. That's 18 electrons. Now, if we were looking at the periodic table, 18 electrons would be argon, okay? And argon is not one of these answers. So which of these could be like argon? Now, it's not oxygen or neon. Those are nowhere near 18 electrons. But here's K plus, Cl plus, okay? If it were Cl minus, that would be, 17 electrons plus an additional one. But this is Cl plus, that's only going to be 16 electrons. So the answer has to be C. Here we have a Lewis diagram for the molecule C2H4. In the actual C2H4 molecule, the CH3 bond angle are closest to, guys, are HCH bond angles. That is a little question that seems like students are confused by. So seeing an example would help them. So they said HCH. So what is this bond angle going to be? And that's what we're asking for. What's this bond angle? Okay, so looking at the question here, we'd say, well, that's steric number 1, 2, 3. So they're going to spread out to be 120 degrees. So we're looking for 120 degrees as answer C. So again, answer the question and then look at the answer choices. Also, if this were on a FRQ and we asked for the angle of the here, then, it might be 120, but a double bond actually repels a little bit more than single bonds. So it would actually be a little bit less than 120. And that's covered here, which bond angles are closest to. But on the actual FRQ, we would accept a range of numbers, maybe between, 118 and 122, something like that. So it wouldn't have to be exactly. So if kids want to figure out, well, it's going to be a little less because of the bond, the double bond, that's going to be taken care of in the scoring. Notice that we have questions here. This one's based on chromatography. And so we'd have graphics talking about these things. So practicing this with kids and get an idea of, this relates to one of the labs that would be useful. And this particle model, particles, you're going to see a lot of that on the AP exam. So in this case here, we'd have to see that these are O2s and this is a C and H's. These are methane molecules, and they're going to answer that question based on this. So you're going to see a fair number of questions using this particle sort of description. Here is a mathematical problem. And now just glancing at the answers, okay, the question here is really, okay, not the calculation, but just roughly what's this answer going to be? You know, because you can see that the only thing different here is a decimal point. So on this multiple choice, they don't have a calculator to use. So they're going to have to learn to work out these answers and just do them without a calculator. Okay, there'll be quite a few things where they're going to be looking at graphs and reading graphs. And so that's going to be an important skill to build up. And when we get to the free response, okay, this is an example of a short question. So it's, you know, it's only 4 points, and so it's A, B, and C. Okay, we're looking at this and saying, okay, this is probably, you know, 2 points for one of these and 1 point and 1 point is how that's going to work out. Okay, this is an example of a photoelectron spectrogram. Okay, and so we'll be talking about those later. Okay, the following question is about sulfur and its compounds. Okay, write the balanced equation for the combustion of sulfur into SO2. Okay, so we'd ask kids to write that out. And again, they're going to have some blank paper after this or lined paper to write their answers. And what happens in here is as they write their balanced equation, okay, they don't usually have to worry about these solids and gases and aqueous. You know, they don't usually look at them. And the other thing is if they get it wrong, they usually don't take any points off for that. So they just kind of looking at the S8, okay, combustion, so plus oxygen turns into SO2. That's what we're going to look for. Okay, B, calculate the volume of oxygen measured at 1 atmosphere and 298 Kelvin. That's required to completely combust 500 grams of pure S8. So that would be a you know, dimensional analysis kind of a problem. Okay, a student gains that. Now also on this one, you're probably going to have to use the coefficients from your balanced equation. And if the student had an incorrect balanced equation, then they would have a wrong answer here. But the people who are reading this would go back and use the coefficients from their wrong balanced equation and recalculate what the answer ought to be. So, you know, if you make a mistake on part A, you're not going to pay for it on part B. You'd have to make a separate mistake. For C, a student claims that the combustion of S8 is an oxidation reduction reaction. Justify the claim by identifying the oxidation numbers of sulfur and S in SO2. Okay, so this is a really common kind of a question, and we saw that on this year's exam. They said, you know, here's a statement that somebody claims. Do you agree with this or do you not agree with this? And justify your answer. And here in the box below, draw a Lewis dot diagram for one valid structure of the resonance of SO2. Okay, if you do this, you're going to find out that it has, you know, couple of resonance structures. Either one would be okay. Now, it's asking the student to draw this in here. Sometimes students will work over on the side to kind of, you know, get a rough idea of what they want. Then they'll put their final answer in here. Now, we're looking for this answer here, but if they only wrote it over here and left it, we would score that and give that credit. Now, this is the rest of this question. Based on the diagram, what's the approximate oxygen-sulfur-oxygen bond angle in SO2? Okay, so once you got your picture, now if this picture is incorrect, then your bond angle would be based on the picture that you drew. So again, you know, if you make a mistake, then we're going to follow along with what you did. Now, SO2 can be oxidized to form SO3. So notice right here between E and F, we've actually changed our reaction. So make sure kids kind of notice that, because sometimes they go back and use information from, like, you know, their first chemical equation. Can be oxidized, you know, here's the delta H is negative. That means it's going to give off heat. Heat's on the right side, it's exothermic. So is the value of delta S for the reaction representative above positive or negative? Justify your answer. So this reaction does form. So delta G is going to be a negative value. The delta H is negative. So the delta S for this, okay, entropy is going to be a positive value. And notice here that, here we have 3 moles of gas turning into 2 moles of gas. That's getting a little bit less disordered, a little less random, and that's going to be a positive, less random. Okay, that's going to be a negative delta S for this. Okay, is the magnitude of delta H for the reaction to form SO3 liquid? Okay, this is SO3 liquid. Here's SO3 gas. Okay, so this is talking about the reaction above. This is talking about this reaction. So here's SO3 gas, SO3 liquid. So would the delta H for this reaction be greater than, less than, or equal to the delta H? Well, if you went from you formed delta G and had this number, then to go from gas to liquid would release even more energy, so it should be greater. And H, based on the information above, how does the thermodynamic favorability of the reaction change? Thermodynamic favorability is the way we talk about being spontaneous and not spontaneous. Change as the temperature of the reaction system is decreased. So we said this is negative. If this is negative, then heat's on the right side. So if you lowered the temperature, decrease the temperature, okay, then it would drive it more to the right to be a more product favored. So the thermodynamic favorability would increase. I think I did that. Okay, here are the answers to that. Go back and see if we got the right answer. I don't want to. Okay, and the scoring information for the FRQs is on the AP Chemistry page in AP Central. Now, there is a periodic table that the kids will have on both portions of the exam, the free response and the multiple choice. And thing to notice is that if you see older exams, they had changed it a little bit. They put in these guys in 2016, these elements were named, and so they were included in the 2019 exam. And they come from NH113, okay, and that is comes from Nihon, which means Japan. Okay, next one comes from Moscovium, means Moscow for Russia. This one here is from Tennessee. I don't know why Tennessee is in there. Okay, and the last one is for this guy here, Yuri, where's his name? Yuri Oganessian. Okay, and so they call the they call the element Oganessian, one of the scientists who worked on making some of those elements. Okay, the last thing is that there is a constant equation and constant sheets that are going to be on both portions of the exam. It's the same sheet. So kids have all this information to use during the exam, and these are all the definitions. A couple of things that are different. They put in Beer's law, and they changed the variable they use. It used to be A equals ABC, and now it's little epsilon. That's it.